Today I'm going to be testing HF antennas to be using in a small flat, and maybe got some surprising results. Sorry about the dropping noises, there's raindrops falling on the metal parts of the balcony, but the metal parts are the parts that are going to be useful, because what I've discovered is I can use part of my metal balcony rail or window frame as an antenna. If you look at the out the window here on the balcony, this metal frame is isolated from the metal that runs along the bottom. So what I've actually done is I've made a connection to the top aluminium frame and the bottom aluminium, which actually has more running along the outside of the balcony than the inside. But I've made two connections. Whoops. Red wire connected to there and the black wire connected to here. This is only a short piece, but hopefully I'm not going to drop this. But if we look out over the balcony, you can see on the other side there's a long piece of aluminium, goes all the way along the bottom. So that's like my ground or ground poise, and the top part here is then the radiating part of the antenna. And the question is, will it work? Let's close the door, keep the noise down. And the other antenna I'm looking at is the loop antenna. This is a thin wire loop, enamel copper wire, with a little tuning device at the bottom which has a variable capacitor on it, so you can adjust the frequency. This allegedly covers something like, I think it's 6 to 50 megahertz, something like that. I'm going to need this to go with it though. This is garlic, you'll see why later. So to test antennas, I use an antenna tester or an SWR analyzer from MFJ. It's an old one, works really nicely. Let's switch it on. It's powered with 12 volts. It says 12.8 volts is okay. And currently it's looking to around about 7 megahertz. So if I tune the frequency, and it's connected to that antenna I just showed you on the balcony metal parts, red and black, connected to the inner and outer coax. And as I tune the frequency, you'll see the SWR changing on this meter here. As we know, above 3 to 1 is horrible and lower is better. Let's see what I can get. That's 6.44 megahertz. So as I'm changing the frequency here, there's a dip, and that's at 7.3 something. So that might be okay for 7 megahertz. It's not perfect, but it's just a random length of wire that I've connected, twin wire like bell wire, to go outside to those metal parts on the balcony. So it really is a random length. I didn't measure it at all, and I'm just pretending that it's a balanced feeder. So around 7 megahertz, it looks like it might be a little bit resonant, that whole setup. There is the dip, and what happens if I go down? There's a dip there as well. Look at that. Around about 5 megahertz, I've got a much lower SWR. 1.5 to 1, that looks really healthy. Goodness knows how this is, well, it'll radiate, but certainly it seems to match the impedance. And then there's another dip around 4 megahertz. Is not really very significant. So 5 megahertz or so, there's a nice dip in SWR there, and then at somewhere around 7 megahertz there's a dip, 40 meter band. And then let's go up, that's 10, let's change range to the 10 to 27 megahertz range, go down to 10, and then start increasing frequency. It doesn't seem to resonate at 10 megahertz, does it? And there, oh, there's a bit of a dip. Wow, around about 18 megahertz, 17.5, 18, there's a dip, where there's an amateur band, of course, at 18 megahertz, so that might be useful. And then let's go up, 21, 22, 24, nothing really, no, nothing useful. So 18 megahertz seems to be the best frequency, provides the best match for that antenna, and 14 megahertz is a band that interests me, and there you can see the SWR we're coming out of the dip. So there at 14 megahertz, we've got about just less than 2.5 to 1, which can be usable. It's like a long wire antenna, random wire that needs matching with a matching unit. and as I increase frequency it gets much better towards 18. I've tried this antenna, of course, and I can receive lots of signals on 14 megahertz, 20 meters. And for transmitting, then of course it needs a matching unit, which is here. Another MFJ device, antenna matching unit, antenna tuner, ATU we used to call those in the good old days. So I can use that to match the antenna. This loop antenna doesn't need the ATU. I've only mounted it on there as a way of holding it mechanically to stop it flapping around too much. So the ATU is not in use, it's on straight through when I use that antenna. But as you can see, the random piece of wire connected to some metal on the balcony seems to be a nice match at several amateur band frequencies. Just for comparison, let's have a look at the loop antenna, what that can do. So if I disconnect this balcony antenna, plug in the loop, which is on the ATU but set to straight through mode, so it goes straight through. Let's tune the antenna analyzer to 14 megahertz. Oh, you can see I've done this already. 14 megahertz. Look at that, very low SWR because this is already tuned. But if I put my hand on and off of the metal case, you can see the SWR changing a bit. Actually not too much now. And by adjusting this knob I can adjust the tuning. Whoa, it's super sharp. You only have to move this knob a teeny weeny little bit, and as you can see the SWR is all over the place, but you can get it down to about 1.1 to 1. I'm holding the knob, and if I take my fingers away, it goes up. So what I need to do is to use the antenna only when I'm holding the knob, or arrange it differently. In fact, if you overshoot with the tuning, that's going a little bit too far clockwise. Take my hand away, no, it was the wrong way. Then go below, too far to the left, take it away, yeah, then it drops down. So what you have to do is tune the knob on that antenna a little bit to the left of where you need to be, so that when you take your hand away, the SWR is nice, very low, 1.1 to 1. But of course, as soon as I put my hand close to that tuning knob, then the SWR rises, which is not good, which is when the garlic comes into play. Because what I want to do, being a bit of a person who likes to experiment, is first to open the pot of garlic. It doesn't have to be garlic, of course, it could be peanut butter, would be better, because this stinks. This is not a good idea. And what I want to do is to glue, maybe, this plastic lid onto the knob for tuning, so that when I tune the antenna, I'm not getting too close to it, and then the effect of the hand capacitance will be less. That's not the optimal arrangement, and oh, that's really smelly. Fried garlic, so that's the wrong plastic lid to use, but just to show the idea, something that needs to be done. This needs to be designed with a bigger knob. Maybe I can get a proper radio tuning knob with a 1/4 inch spindle that'll fit onto there in place of that one, because it's just too small. And the next thing I'm going to try, of course, is connecting a radio transceiver to see how it works on receive and transmit the two different antennas. Meantime, you'll be pleased to hear I found the upgrade for the garlic lid, which is this one, peanut butter. I'm going to use this plastic lid instead to mount on the tuning knob for my loop antenna. So what I've got now is not a transceiver but a receiver. This is the loop, which I'm going to be showing you in a second. This loop with its tuning mechanism connected to, straight through the ATU, to a receiver, an sdrplay RS-PDX, which I got yesterday in the post, and I really like it. I've installed it on another computer last night, the software, the SDR Uno software, and that works really well, and I was having great fun listening around the HF bands with it. And today I've installed the software on a laptop. I haven't had a chance to test things out properly, so this is a laptop running Windows 10 with SDR Uno on it, and I've set the sampling rate to 10 megahertz, which means we can have a sampling bandwidth total of 10 megahertz. So it's scanning from 11.5 up to 21 megahertz. So it's about a 10 megahertz band. And the receiver, the SDR receiver, is connected to that loop antenna. And what I'm going to do is tune the antenna, and you'll see the noise peaking up and down the band, showing the resonance of the antenna. And no, this is not a comb generator that I've set up in order to demonstrate this effect. This is actually local interference every 400 kilohertz or so. As I said, I only just installed the software a minute ago and got the receiver working, so I haven't had time to investigate where that signal's coming from. Maybe it's being generated inside this laptop itself. That sound is interference from the neighbors, which is drilling holes. They're having some renovation work done. Anyway, I'm going to tune this tuning knob, and you'll be able to see, hopefully, on the spectrum display, as I move the knob, there it goes, there's a peak in noise moving from right through the center to left. I hope you can see that. It's down at 10, 11 megahertz, and then moving slowly back up, there's 14 megahertz. And it seems to go as far as about 17, 18 megahertz at the moment. Which is interesting because this loop does actually work up to 50 megahertz. I've tested it, some kind of a secondary resonance effect. But this primary tuning seems to go from below 10 megahertz because it's supposed to include 7 all the way up to 18 or so. So that's an easy way of tuning the receiver. You can listen to the noise, of course, audibly and adjust the antenna, which is what most people do. You can just look at the noise visually like this to tune the antenna. Well, there's a signal popped up. Or you can, of course, transmit and then measure the SWR, which is probably the best way of doing it, but it has to be done with low power so as not to cause interference to other users of the spectrum. So, something else I can demonstrate maybe is if I touch the touchpad on this computer, and this is a plastic computer, it's a cheap Lenovo laptop from the V series. It's very flexible and flimsy. I'm surprised the circuit board doesn't crack when you pick it up. It's really flimsy and not very well shielded at all compared to the ThinkPads, which have solid magnesium or aluminium chassis underneath. And when I touch the trackpad, you may be able to see, or I can certainly turn up the volume, you can hear the noise. There's some noise popping up and down. You can see those little spikes appearing, disappearing, reappearing, and if I turn on the speakers and we listen to the noise, then that rasping sound is coming from the trackpad. Goes away, back on. Maybe you can see it better when I... So you can hear that's noise being radiated from the trackpad. From the keyboard there's not so much. From the display there's not so much being picked up. It's the trackpad. I have other laptops that have other noisy parts and computers. We'll look at that later on. How to use different cables to block USB port noise. Like this USB port has a ferrite tube, in fact, on it to try to block the noise. I've experimented with these and found much better solutions that really block noise. I'll demonstrate that soon. So that's the use of noise and local interference in tuning antennas. And let's see what happens next. One thing worth mentioning for users of SDR software for this kind of receiver is I said I set the bandwidth to 10 megahertz. I didn't say how I did it. It's not obvious to me. It took me a little while to find out. I even had to look in the manual. And that is, if you select the frequency using the band select button, like here, for example, I've clicked on 20, meaning 20 meters, 14 megahertz. You can see the display shows 14 megahertz. And if you look here, there's nowhere to change the received bandwidth at all. That setting is hidden. What you have to do is click on the band button again, like this 20 meter one, and to make the green light go off. Now the green light is off. And if you look back here at the receiver control panel, you can see that now there are a few more buttons. The most important one is this one. There's still no bandwidth that can be changed, but there's this IF mode, LIF, and we have to click it so it changes to ZIF, zero IF mode. And then in ZIF mode, you can change the sampling rate, which is here. The default is 2 megahertz. Now you can click this and you can choose the sampling rate that you want to use. And I had chosen 10 megahertz earlier. So it took me a while to realize why those buttons were missing, and I couldn't make that change until I realized that by using the band selector, you deny yourself the opportunity of changing the sampling rate. It's in the manual. So let's move on and replace the laptop receiver using the sdrplay SDR receiver. Replace all of that with this, a Xiegu, let's call it Xiegu X600. I'm sure there are many ways of pronouncing that name. X6100 I mean. And I'm going to use that to have a look at a few things like USB noise, and we're going to use this computer as a terminal for FT4 and FT8 and so on. So let's do that next. So here's the X6100 being used as a receiver on 14 megahertz on a quiet part of the band, connected to the loop antenna again. And of course normally you would not operate a radio right next to the loop antenna, such a close proximity, because any interference generated here is going to couple directly into the antenna and cause problems. Normally the antenna should be as far away as possible, especially when transmitting. But for the purposes of the experiment, it's interesting to see, because I can see what's being radiated, like from the trackpad of the laptop. Here, for example, when I touch the screen, the display screen of the X6100, just turn up the volume a bit, you can hear noise being radiated from the screen itself. And this is not a touch screen, it's just an LCD, but because of the scanning of the pixels in the LCD, there's noise generated, and this is radiated out when you touch the screen. Hopefully it's got some kind of thin conductive shielding material on it, but still it's not perfect. But when you're not touching it, the radiation is small. What I've done is I've got this Windows laptop not running any programs, and a USB cable plugged into a USB-A port to a USB-C plug at the other end to plug into the radio to be able to transmit data between the two and audio and controls. And already, if I just touch the ground without plugging the plug in, you will see an enormous amount of noise appears on the receiver. I didn't even put the plug in, and you can show this even more easily just by touching the ground of the USB plug to the ground of the antenna connector. Look at that enormous amount of noise. It goes from S5 to S7 or more. So that's 2.5 S points of noise, white noise generated by the laptop. And by playing around, I discovered a way of getting rid of that noise coupling very easily, and that is to remove that normal USB cable and plugged in another normal USB cable, but with this one I've put on these two ferrite blocking devices. We used to use chokes and ferrite rings, and these are not rings, these are tubes which are split in half so you can open it. And what I've done is I've put 2 turns, in fact 2.5 turns of the cable through it to try to give as much blocking as possible of noise and carried on the outside of the cable. I've done this by both plugs. So now let's plug this into the laptop USB port, USB-A, and now with this cable, if I just touch the ground onto the ground here like I did before, there's a little click, but there's no visible or audio increase in noise really. I can just hear a little click when the contact is made, but that's it, nothing else. So of course if I touch it onto the USB socket of the radio marked dev device or developer, you really don't hear anything. So I can safely plug this in and then go ahead and look at the data coming out of this radio. Connected the radio, the X6100, to the laptop, and spent a long time fiddling around with the wsjt-x software trying to get it to work, and I've given up for now. There's audio going in over the USB port. You can see the audio indicator on the wsjt-x software, but it is not receiving any stations, even though there are plenty of signals. So I gave up for a while and just tried on a different Windows 10 computer. All the settings are the same, and this works fine, of course. So what I have here is the X6100. You can see there's some pretty strong signals coming in. Turn that off. So nice signals coming in. That's coming from the loop. No, it's not. It's from the balcony antenna, made with the metal parts of the balcony and through the ATU. And then this is feeding into a bigger Windows computer, and this works fine. As you can see, there's plenty of signal coming in. Here's the spectrum of the FT8 or FT4 signals. That's working fine. I turned off the AGC and I set the bandwidth to 3 kHz on the receiver just to fill that up. And looking at this, you can see there's data flowing, stations contacting each other as you would expect, and so the software is working. The wsjtx software, there you can see version 2.6.1 was very easy to set up. Plenty of videos about it on YouTube, so I won't go into details here. And there you can see on the left hand side is the received audio levels a little bit too high. I need to turn it down, but it works fine. I still can't work out why the laptop is not able to display this data, even though I can get the audio signal into the laptop on the USB cable. I've also tried that laptop with a different receiver using the RSPDX from sdrplay, which also receives signals and outputs them through a virtual audio cable. And again, the wsjtx software refuses to decode anything. So I'm a little bit lost at the moment why that doesn't work on the laptop, but it certainly works on the bigger Windows 10 computer. So that's it for now. The next episode follows. Please remember to like and subscribe. See you again.